We can do the same conversation.
No, I'm not going to.
You know water's the root of all kinds of
Stop that. All right, number 2. Man, I'm really struggling here today. Number 2 is addition. Add prop. What do we do on number 3?
You put 17, 5 minus 17.
Yeah, you subtracted. S-U-B-T period prop period. Don't just put S-U-B because that stands for substitution. Number 4, fill in the blank here. 5x plus 1 equals 21. We're proving that x equals 4. What's the first step to a 2-column proof?
Minus 20.
Minus 20 is not the first step to a 2-column proof.
Oh, dude, given.
Given. Thank you.
That's what we do.
And then we subtracted, not 20, but we subtracted 1. So we use the subtraction property there. Lastly,
20 minus or 20.
division.
Oh, okay, I see. We're speeding through this.
Questions or repeats? Let's continue. Okay, number 5. We're just justifying each step. It gives you the equation. From there, it's telling you this is the step we're going to do right here. What did I do on that step? How did I get from the first statement to the second statement? Multiplied. So that's the multiplication property. From part A to part B, what I do? Not yet.
Oh.
Yeah, a lot of people do that. You kind of get ahead of yourself a little bit.
Wait, so which one are we looking
From part A, look at part A. What do I do to get to part B?
Oh, you would multiply. Or wait,
What do we call that?
Oh.
So 2 is knocking on the door of this parenthesis party, right? Wants to go in and meet everybody. Distributive property.
That's a thing.
You've heard that
Do
before.
I have to put property after everything?
Why not?
Just put prom. Abbreviations exist for a reason.
Yeah, we can abbreviate, but let's not abbreviate a ton. And then lastly, from B to C.
Add. Or add 10.
We added, right? Added 10.
Do we take points off if we don't say distribute? Or property? Because I haven't been for like the past 3 hours.
Number 6. Why don't you guys try number 6 on your own? See if you can whip through that.
Of course. Oh.
Got it? What'd you get for part A, Aiden? No idea? Lost?
No idea.
Aiden? Distribute, yeah. Makes sense now. So from this statement here to the second statement, I'm going to distribute that 5 in. And then what? Lauren? Yeah, you subtract over 15. Then the last one, hopefully you can see that. That's division property.
I could not.
Okay, number 7 is where we add a little bit of geometry in here. Angle CDE and EDF are supplementary. We know that because they form a linear pair. And then the next step it says CDE and EDF equal 180. CDE and EDF added together equal 180. How do I know that? Because they're supplementary.
Bam, I'm smart.
Okay, now look, it's that word supplementary that tells us to do that, right? So it's that the definition of that word. It's the fact that we know what that word means, and it means to do this, okay? So the reason here is definition. Whenever you have a word that kind of tells you to do something, a lot of times the reason you do that then is by the definition of supplementary, just definition of supplementary. So that's the geometry stuff. That's kind of new. And the rest is algebra. Nope. So I take out from the part A to part B, I take out CDE, I put in X, I take out EDF, and I put in 3x plus 20. What do we call that? Learned that in algebra. Take out one value, and you put in what it equals. Substitution, good.
There's a lot of sneaks.
Mm-hmm. So that's why subtraction I use a T at the end. Substitution is just sub. Sub it in. Now you should be able to.
Distribute.
No.
God dang it.
Loves you.
I mean, gosh. It's gosh.
Good question.
Add.
Add, yeah, you take X and 3X.
Who made that? You're filling it out now?
I've been filling out this whole time.
No, I mean.
Oh, I'm a step ahead, aren't I?
Yeah.
So yeah, from there, 4x plus 20 to 180 equals 180. So the next step, it goes to 4x equals 160. So to get there, I subtracted over 20, and then the last one, everybody is divide.
Everybody. I'm really good at this.
Number 8. Again, some algebra, xy equals 42. They're giving that to us. Then it says xz, those letters, plus zy, those letters, equals xy, the whole thing. Those letters, right?
I can sleep.
So this is a geometry concept. What did we call that? What property was that? Where I can take these letters, which stand for something, we can add them together to equal these. Huh?
You define them or whatever that was.
No. Oh no, it's not a definition.
Distribute.
What am I doing? What do these letters stand for? What are these?
Points.
Points. Yeah, kind of. So when xy is 2 points together, what is xy or xz? Segment. Yep. So what are we doing to these segments? Adding them together to equal a bigger segment, right? All should be ringing a bell. What property did I call that? It's real simple.
Add
What are we adding?
the two segments.
So it's segment addition. It was actually a postulate. Segment addition postulate. I think I put property here. Let me back that up.
Taking a little too fancy with their problems.
And then take it from here.
Multiplication.
Nope,
Okay,
you take out the xz and you put in 3 times quantity m plus 4. Substitution, and then you can take it from there. Why don't you guys try that? What'd you get for part B?
Sub.
Substitution. And then part C?
Multiplication.
Distributive or multiplication. It's kind of the same thing, right?
Yes.
Part D?
Add.
Yeah, we combine like terms of 3n and 3n, so that's addition property. E?
Subtraction.
F.
Division.
So what we have going on here, guys, is sometimes you look at part E. When you look at part E, you want to think division, right? When you look at part E, you think division. It's understandable. But if you use division there, then you have nothing to use for F. So a lot of times people kind of get ahead of themselves. You got to slowly think about what's going on from the previous step to this current step.
So in like problems like these, is division always going to be your last step?
If your second to last step looks like this, yeah.
What if it looks like a fraction?
But like up here, your second to last step wasn't division,
Yeah.
right? It was addition. So yeah, good point. Any questions or comments or repeats? No.
I just did something stupid.
Okay, number 9.
Darn it, I'm not
We are
gonna
just
though.
stating what we got from the first statement to the second statement. What do we do? Rapid fire, let's go.
What is this?
Something or other.
Subtraction, we just subtracted over 1, good job.
What are we doing? I can't.
Name the property.
9, 6,
Okay.
Division.
How did we get from the first step to the second step? You guys see that? Lexi, you good?
Do we put the property or just do?
Division prop, yeah. 11 is a new one. You probably were taught it in algebra, but it just doesn't come up a lot. Seems a little silly to say. But on number 11, ST is congruent to QR. QR is congruent to ST. Makes sense, right? It's the same forward and backwards. It's like A equals B and B equals A.
that'd be like equal something.
That is what we call a symmetric property. It's the same forward and backwards.
How do you spell it?
Symmetric, SYM, period prop. Period. Just abbreviate it.
You just left the problem. Hold on.
Number 12, look at it closely. We have AB minus BC equals 12, and then it goes down here, and AB is still on the left side, equals 12, and now BC is on the right side. What do we do? How do we move that BC over?
Yeah,
Flipping problem.
You just added it over, right? So that's addition property. You say a flipping property?
Yeah.
Nope, that doesn't exist.
It will now. Wait, how do people like make these properties? Does a sign like a famous sign that says this is
probably
this?
Greek.
Basically,
I'm
yeah.
gonna get famous so I can do
Math
that.
mathematicians were like, okay, in order for this to hold true, we have to have certain properties that hold true. So let's
I'll
make
become
these
that.
properties true, and
How
they.
do you know that the math is right?
You don't.
Math is just a concept.
I don't know,
You
guys.
assume it's right.
Here's what you got. Like, if there's 2 acorns over here and 3 acorns over here, and you combine them, then there's 5 acorns. Like,
Well, then who came
that's
up with
pretty.
the concept?
What
That's pretty solid, right?
Who came up with the concept of numbers
The Greek god Athena.
And I'm pretty sure like some Middle Eastern dudes expanded on it.
I could
It was
spell
Zeus.
stupid if that's
And then the Indians found out about all that, and the Indians started doing some weird stuff with numbers.
I got one.
13. It gives us C as the midpoint. That's good. We should know what that means. We want to prove that x equals 6. It gives us the answer. We have to justify our steps. First step to a 2-column proof is to state the given.
Okay then.
Should be able to do that step.
I think we done did that step.
All right, everybody with me?
Yeah.
Okay. So, C is the midpoint. What do I know based on that phrase? That
That's
A
the
word.
Point.
what's that? It's halfway, yeah?
Both equations combined.
Okay, so what do I know? I know that AC equals CD. Okay, what word told me that AC equals CD?
Definition.
What'd you say, Aiden?
midpoint.
Midpoint, yeah. So we take the word midpoint and we understand what that means, right? It means it's right in the middle, it's halfway. It means that each side of that midpoint is going to be equal. AC is going to be congruent to, I should say, CD. So definition of midpoint tells us a lot there. tells us that we can set AC and CD congruent to each other.
Fine.
Then AC and CD are equal because they have the same equal length. And then from there, we took AC and plugged in 4x, took CD, plugged in 2x plus 12. What was that? A substitution.
It's so hard to write.
This time they give us the reason, subtraction property. They want us to give it the statement this time.
Oh.
2x equals 12. Would work.
Division. I can just do it.
Wait, what'd you say?
Wait. Isn't E division?
You sure?
Yeah. Yeah.
Yeah.
I'm just messing with you.
Oh, this is
If you would have stayed silent, I would just like, dang.
Okay, then we're doing evens from here, 14 to 34. Any repeats there, number 13? Tanner, you got it? What? You- we need-
repeats, I guess.
Oh, no repeats, okay. We talked about the symmetric property. AB equals YU. Then, symmetric that is same as forwards and backwards. So if AB equals YU, then YU equals AB. Kind of a weird thing that we have to say, but you know, it helps us with those arguments. For example, we don't have to do 15, but I'm going to talk about it. For example, the reflexive property is a little bit weird. The reflexive property is what I call the it is what it is property. It is what it is. So if somebody, you guys are kind of starting to get into some deep thought, right? Like, oh, math is a concept, and like, who made up numbers? And so there's a property here that says A equals A. So instead of two people arguing back and forth like, A equals A, are you sure it equals A? How do you know A doesn't equal B? Well, it's because A, so A has to equal A. It is what it is. They're just like, let's just stamp this with the reflexive property. Let's say that this is a property that holds true, and let's just move on. Okay? So the reflexive property is, in this case, if we had to answer this one, angle POR is congruent to angle POR. POR is congruent to POR. It is what it is. Reflexive property is where something's equal to itself. All right, the next one down here, distributive property. So 3 times the quantity x minus 1 equals 3x minus 3. On number 18, a lot of times what you have to do is look at the figure, kind of what we did up here. Look at the figure, and it will tell you some things, and we can state those things based on the figure. So what do we know about this figure that hasn't been stated? Well, nothing's been stated. So what do we know about this figure? What's just some statements we can make? Yeah.
Angle 1 and 2 are supplementary.
Yeah, angle 1 and 2 are supplementary, right? So that means angle 1 and 2 add up to equal 180. Yeah, they're a linear pair. So I can put that down. Angle 1 plus angle 2 equals 180 is what I'd put. I know that. Okay. What else do I know?
Can we write that down?
Angle 1 plus angle 2 equals 180. I'd write that down. Somebody besides Aiden, what else do we know?
That those are angles. I mean, that isn't true.
Keep trying. Keep trying. We want something productive, okay? I mean, that line is black is what we know. Yeah, okay. And something productive. What else do we know?
Angle B.
Lauren?
Angle 2 and not angle, I just lost my train of thought.
We're going to use vertical angles. I thought maybe that's where you're going.
B.
Huh?
B.
What about it?
Straight angle.
B is.
Wait, oh, D. Wait.
D's a point.
What?
An angle is named using 3 points. ABC is straight. Okay.
You know what?
ABC equals 180, right?
DBE.
There's one more big one here I want to get to. Aiden.
Angle ABB and EBC
Are they the same?
yes.
They're congruent. ABD, this angle right there, is congruent to angle EBC, which is what I thought you were trying to say, Lauren. Angle 2 is congruent to angle ABD. Yeah, we know that, guys. That's good. That's great. It's given through that figure, right? One more thing. We haven't said yet. We haven't stated it yet. What do those indicators mean right there? What's that mean? Okay.
Either or.
So what is congruent to what?
DB and BE.
DB is congruent to BE. So here's a couple more. B is midpoint. Someone told me that. DB is congruent to BE is the big one I wanted to say. And then angle 1 and angle 2 are 180. You guys already have that one down. I wanted to state that one too. All right. The rest of them we'll do tomorrow. Now tomorrow, don't take tomorrow off. You'll have a whole next week off, okay? Tomorrow, we'll have a worksheet. We'll finish this also. So log on to Canvas tomorrow. Make sure you're counted present. And don't take tomorrow off.